Assalamualaikum and good day everyone. Today we will learn on the last subtopic in chapter 7, which is estimation of Sx. So how to write the estimation of Sx? We have to put Sx with the hat. So Xx is the survival function, which is the multiplication of the probability of survive, the Px. So Sx is the multiplication of P0 until Px minus 1. So there are two assumptions in finding the expected value and the variance. So the first one is, since the Pi is approximately an unbiased binomial proportion with mean Pi, and the variance is Pi times Qi over Ni. So Pi in binomial, Pi as the success, so Qi or 1 minus Pi is the fail. So the variance for binomial is Pi times Qi. However, this time is unbiased binomial proportion. So we have proportion here. That's why for the variance we have to divide with the Ni, since it is the conditional situation where the Ni is the exposure, the Pi the success only for the Ni, the total of the exposure. As a recap, in previous subtopic for the exposure, so Ni is the exposure of the extent to which the group is exposed to the risk of dying. Denominator for Qx is the exposure. So the summation of the Si minus Ri. So we have exact and scheduled exposure. So that one is the Ni. Okay, that's just the recap. So the second condition on the set Ni, the Pi's are mutually independent. So the expected value of a product of independent random variable is the product of their expected values. I will explain more in the next section for how to find the expected value and the variance. The first one, how to find the expected value of Sx. It is a conditional on the set of exposure. Product of the conditional probability. So as a result of the independence assumption, we get actually the expected value of Sx is the multiplication of the probability of survival. So Esx, since it is conditional probability, so it given that Ni is the multiplication of probability of survive is equal to Sx. And the variance is also conditional on the set of exposure. So approximate binomial samples underlying the estimate of the Pi. So how to find the variance? The second moment minus the first moment squared. So from that first principle, And the definition given in 7.2, so we got the Greenwood formula, whereby the variance for the survey function, given that the exposure, the Ni, approximately equal to Sx squared times the summation of Qi over Pi Ni. So the important formula you have to know in this subtopic is how to find the variance and how to find the expected value. So only two formula that you have to know for this subtopic. So we try example 3. In a study using a moment estimation approach, we observe the following numbers of death in estimation interval x and x plus 1. So you are given the interval, death, and exposure. So the death actually is the number of death is di, and exposure is Ni. So I represent which participant. So first, you have to fill up the table. So Ni is, just take from the question, the information given. So Ni is 1020, the exposure. Ni is the exposure. 1020, 1100. So how to find Qi? So Qi is the probability of death. Qi is equal to di over Ni. Remember, number of death over the exposure, or number of the who contributing in the observation. So 20, number of death is 20 for I equal to 0 over 1020, and number 1 is 16 over 110, 0, 14 over 1171, 14 over 1287, 16 over 1592. And the Pi, what is Pi? Pi is 1 minus Qi. So this one is 1000 over 1020. This is 1084 over 1100, and 1157 over 1171, 1273 over 1287, 1576 over 1592. And then you times Pi with Ni. Why? Because we want to use this formula. So we have Pi times Ni for the denominator. So it's easy now to find the Pi and Ni. So we got 1000 here. So the Qi over Pi and I, you substitute all the values. So we get 20 over 16 over the Pi times Ni. This one is 14 over 1171 times 1157. This one is 14 over 1287 times 1273. This one is 16 over 1592 times 1576. So after you finish, fill in the table, so you can estimate S5 and variance for S5. So first one, how to estimate S5? So the notation for estimation of S5 is S5 with the hat is actually the multiplication of P0 until Px minus 1. So until P4, 5 minus 1. So P0 is 1000 over 1020. You can just take the values from the table that you have filled in. And the answer is 0.9347. So from the table, you can find the variance. So approximately we're using Greenwood formula where S5 squared times the summation of Qi over Pi times Ni. So you take the estimation from previous answer. So the summation from Q0 until Q4. So you substitute the values. And the final answer is equal to 0.00005092. So this is how you find the Sx with the hat and the variance for unbiased binomial proportion. So we end chapter 7. Thank you.